Hello everybody, welcome back to Cement Manufacturing Practice Series, second episode on Chemical Industries Engineers channel. In this series, we will focus on Portland cement, and in this episode, we will talk about the raw materials and its reactions. The proportions of raw materials vary from type to another, and from plant to another. In some cases, we get either one material which has the required component, so we don't need any other raw materials, but in order to maintain this material, we should mix it with other materials. Or may we get high-grade limestone with high calcium carbonate content, but also in order to maintain this grade, it mixed with low-grade limestone. So we will mix two or more materials with different proportions to make a feedstock, with overall proportions not less than 75% of calcium carbonate, not more than 22% of silica dioxide, not more than 6% of alumina, not more than 5% of iron oxide. And these materials contain other components which may be harmful to the process, like alkali and sulfur compounds, which may cause build-up in burning equipment and may affect the quality of cement. So, the ratio alkali to sulfur should be about 1 plus minus zero point 0.2. About the reactions, when raw materials enter the burning step, calcium carbonate start decomposes to calcium oxide and carbon dioxide, as I mentioned in the last episode, at 650 to 900 degrees Celsius, which called calcination or calcining. And then the reactions between calcium oxide and other components start at 12 and 50 degrees Celsius to produce new compounds like tricalcium silicate, which called alite, dicalcium silicate, which called belite, tricalcium aluminate, which called aluminate, and tetracalcium aluminoferrite, which called ferrite. And these compounds form a new material which called clinker. To get good quality clinker, the proportions of these compounds should be not less than 70% of calcium silicate, with not less than 3 to 1 ratio for alite and belite respectively, not more than 16% tricalcium aluminate, not more than 70% tetracalcium aluminoferrite. And about undesirable components, its limits determined by the standards of a country, but in general it should be not more than 2% of free lime, not more than 3% alkali sulfates, and very low dissolved carbon dioxide and moisture content. The question now, what's the importance of these components? Alite has high content of calcium oxide, which give it higher reactivity than other calcium silicates. It's the most mineral in cement, and it's responsible for the early strength of hydrated cement. It reacts with water to form hydrated calcium silicate and calcium hydroxide, unlike belite, which gives the cement late strength because it has low reactivity compared to alite, and it reacts with water to form hydrated calcium silicate and calcium hydroxide. While aluminate is the most reactive component in the clinker, so it has effect on the early setting of cement in first few days. Its reactivity leads to flash set, and to avoid this, small additives of calcium sulfate is added with a specific amount, 4 to 8%, to form ettringite, and then ettringite reacts slowly with aluminate to form AFM phase, which contribute little to strength. In general, aluminate undesirable in clinker because it has many undesirable effects, like heat release during hydration, which can cause overheating, so its level reduced where necessary, and sulfate reactions, which can cause fall up to concrete. So in cases where the concrete is exposed to surface contains sulfate, low aluminate content cement used, or slag added to the concrete mixture to avoid undesirable reactions. Where ferrite is mainly useful to reduce the melting point of the feedstock to about 14 and 25 to 13 and 50 degrees Celsius. In hydration, ferrite form hydrated tetracalcium aluminate and hydrated iron oxide gel in fast reaction. And iron oxide gel make a layer on the ferrite crystals and make the next reactions more slowly between ferrite crystals and the soft sulfate to form AFM phase, which become in two forms. There are small research about this compound, so there is not enough information about it. Finally, I hope this video is useful. And if you work as a chemical engineer in cement factory and interested to share your knowledge and experience with other engineers, please feel free to contact me at any time at my LinkedIn account. And don't forget to like, subscribe, and share the video. Thank you.